I got two parcels today. They're printed circuit boards, and you may recognise that these are the packages from JLC PCB. Not sponsored, I'm not doing this as a review, just to show a bit of opening up the boxes. I have to confess I pre-opened them in the office today, have a quick look. So I've just cut the tape on here, and there is the first board. This particular board, I designed this in KiCad, free open source PCB design package. It's intended as a kind of a breadboard. The design here, this is a TQFP 64 part, surface mount part. This bit of a board over here can be broken off along, I hope, along these perforations, and that turns it into a breadboarding design where you use this to fit into a solderless breadboard, and you put a right angle connector on here to plug into that. All around the top here, on the kind of igloo shape at the top, those are LEDs and connectors for them. These connectors here would be for connecting probes or debugging or oscilloscopes or something like that. So that's the Igloo 64. I'm very pleased with that board. It looks like it's come out okay. Back of it's a bit blank. I wish I'd done something with that. I wish I'd put some silkscreen on the back, made a pattern or something on the back there. Maybe a second revision. I've only got 5 of these. That's how many you get when you go for the cheap option at JLC PCB. So maybe I'll make another revision with something interesting drawn on the back here. I'll have to see about that. So that's the Igloo 64, 64-pin TQFP to 64-pin solderless breadboard. Right, what else have we got? The other box contains another board, a slightly different design. This one is hexagonal. There we go. So these boards, let's fetch that out of there. Get the little pillow of silica gel, of course, mustn't eat that. So here we have a board which is hexagonal. Now I'm going to bring the camera a bit closer, I think, to have a look at this. Bring that down just a little bit. There we go. So this board, it's a hexagon. It's a 45mm side on the hexagon there. So it's actually the same size as a well-known tabletop role-playing game, which you may be able to recognise. The idea is that this is big enough for a 48-pin DIL processor or chip or whatever you want to put on there, and then it brings out the 48 pins onto 6 8-pin headers. Now I'd use 2-row headers because I like to have, once again, enough room to put a scope probe on there and a logic analyzer and not run out of pins all the time. So you can see how that's going to go together. Let's see if we can get some more of those. I've got a little bag here of connectors. Let's get those ready so I can fit. These are rather nice yellow connectors. I got these a little while back from China, and they were originally 2-row 9-pin, which is 1 pin too many. So I've actually sawn off a pin on the end of these to make them fit. So there we have 6 2-row 8-pin connectors. We've also got a connector here. So this is again bringing out the 48 pins. There's 24 on here, 24 on here. Where's the other one gone? Should have 2 of these. There it is. That's the one. And there it goes. And then the processor or the chip or whatever you want to put in there goes in the middle, like that. So we've got this is a 40-pin socket, so that's good for something like a 6502 or a 6809 or maybe an AVR Atmega 4809, something like that. There's enough room, if I can find one, there we go, for a push button switch. That would make a reset button. And on the same footprint, there's also room for a 10mm LED, so that makes a nice big LED if you happen to want to make an LED flash on and off. Might as well make it a big one, right? Now, you don't have to do it this way. You can certainly, if you prefer, fit sockets in here. There's pads for a narrower socket, the say the 28-pin 0.3-inch DIL socket. You could actually fill it up with 3 lots of 16-pin DIL sockets. So you'd have 3 maybe shift registers, something like that. You can fit a header in the middle, so you can have another board plug in vertically on here, and then the whole thing will sit on the table flat. And of course, I mustn't forget, let's just take those off, that we've got places to put little standoffs, so we can put a standoff through the hole there in come on. These are M3 mounting pillars or standoffs. There we go. So we've got space, of course, for 6 of those. And if I just fit 3 of them, I can still stand the board flat on the surface. Now, the other thing that I sent off to be made in China was a piece of acrylic. Now, I didn't send the acrylic, I just sent a file, and somewhere in China someone is laser cutting a piece of acrylic to my design, and the idea of that is, have I got this right? Yes, I have. There we go. That one goes in there. No, not that way round, that way round. So the piece of acrylic will be the same size as the board, and with the same holes in, but of course it won't have any of the PCB tracks on it. So it will allow me to stand this board on a piece of acrylic that will pick up on the same mounting holes, and that'll make a little base for it. But I think what I'm going to do to make it a bit heavier, I like these things to be heavy enough that they don't slide about on the table all the time. I'll make a piece of slate. It's quite dense, quite a heavy material, and I can cut a piece of slate roughly the same size as this, and make the holes. The diameter here, the pitch circle diameter, is 82 millimeters. The distance across the tips of the hexagon is 90 millimeters. So if I can mark out, you can mark out a circle and then divide it up into 60-degree segments, and then you've got your mounting points. I hope that works out okay. Again, I've got rather a blank back on the board. It doesn't have much in the way of, there's no silk screen, there's just a few tracks on the back there. So I think that's about all I want to say about that for the moment. This is the Hex 48. The design files for these are on my GitHub, so you can, if you really want to, examine how it was done, and if you're extremely keen, you might even have your own board made, or make a better one. Do by all means take this design and improve it. So that's the Hex 48. This is the Igloo 64. I think what I'll do next with these boards is, obviously I need to hack this one off down here and start populating it. So I'll make another video once I've made a bit more progress with that, and I've actually got some parts on here. Don't know yet what I'm going to fit in the way of a chip on here, but we can certainly get the pins, the headers, the right angle connectors. This one takes the right angle type connector that will go on here, something like that, so that, as you can see, that will give us, I hope that will give us a right angle connection to the little kind of foot over here. These will fit into 100mm by 100mm low cost PCB outline. They don't fit in the 50 by 50, but they fit in the 100 by 100. Okay, so there we go. That's Igloo 64. That's Hex 48. Do have a look at my GitHub.